Everyone, very good afternoon. Warm welcome to our DevOps session. So we are now seeing that we have very less participants. So what we will do is we'll give a couple of minutes and then we will start. So, but we are all set for running the sessions today. So we have our trainer, Mr. Amit, also join in. So like I said, we'll give a couple of more minutes and then we can start the session. Amit. Hi guys, once again, good afternoon. I'm part of SkillUpRight. So we're waiting for the participants to join. I think we have a good number already. So Amit, I think you can take over from here because we already are having about 947 people joined in. So maybe you can quickly, you can just have a small introduction about yourself and then you can start off with the session. Over to you, Amit.
Am I audible?
Yeah, Amit, I'm able to hear you now.
Okay.
Okay. Amit, just before that, I think there are a few questions related to some people are not able to broadcast. Okay, guys, one thing what I can tell you is, we keep hearing that some people will be audio issue or the screen gets freezed and broadcast issue. So basically, there is a reconnect button on the top. Just click on that, it will refresh and it should work. And I hope if you have a good internet connectivity, that should really work fine. Okay, I think it's time for us to start the session. So we have a trainer, Mr. Amit, who is a DevOps SME. So he will be taking over the session. Amit, you can take over from here.
Okay. Vinod, before you leave us, one question that a couple of people have asked me is that would the recording be available for them later? So
okay, great. That's a good question. So what we do is every webinar we record, and after the webinar, maybe about 4 hours later, I think you will receive a mail from us with the link of the recording. That is where you can go and find. If not, even if you go to our website, there is a separate tab of webinar. On the top, you will find all the webinar that we have scheduled for this month. If you scroll down a bit down, you will find all the recordings of the previous webinar. And today's webinar, after 4 hours, I think you will be able to find on the website. Okay, so you will be getting the webinar recording.
Okay, great. Thank you. Thank you, Vinod. All right. Hi, everyone. This is Amit here, your discussion partner for today. I will be talking about DevOps and how it is used in the industry, and what we should learn when we talk about DevOps, right? Is my audio and screen both okay for everyone? Quick check here. All right, looks like it's okay for everyone. So today we are going to talk about DevOps, right? And we have 3 sessions. Today is 20th July, which is first session. Then on 21st and 22nd, we have 2 more sessions at the same time for 1 hour. Okay, so we are going to discuss the length and breadth of DevOps at a very, very high level. My name is Amit. Yep, Amit Kumar. And yeah, I have been in the industry for around 16 years now, right? I work right now as a DevOps principal engineer, and I take care of the entire DevOps infrastructure for my organization, um, along with providing trainings for new people, doing running DevOps evangelist programs, teaching people about DevOps and getting them on board to adopt DevOps methodology. Okay, so I've been working for 16 years now, and my training experience is around 6 years. So do trainings on DevOps. I do training on Kubernetes, on Docker, on AWS, right? Terraform. So many tools which we use these days for DevOps. So Terraform and other infrastructure as code tools, version code tools, and all that. So I do almost all the technologies that are used in DevOps. Okay, and this webinar is designed to make you understand what is DevOps, right? So we are going to understand what is DevOps. In next 3 sessions, we are going to understand what is DevOps, and we will get a brief overview of how DevOps will work, how DevOps works in the industry, and what you should know to be a successful DevOps engineer, what you should start learning, what you should learn before you actually start learning DevOps, and things like that. Yeah, guys, just give me 1 second. Yeah, let me just give me 1 second. Yep. Okay. So we are going to understand what is DevOps and a brief overview about the tools and technologies involved, what is DevOps as a methodology, and how do we implement it, right? So we are going to talk about that, right? So that's the agenda for 3 days. Now, if I have to break down the agenda day wise, today we will talk about specifically DevOps as a methodology, and we will understand what it DevOps, why do we require it, and how do we implement it, right? And in the what and why part, we will understand, how the things were before and how things are now, like a story, right? We'll see DevOps story, how it came into being. So that's what we are going to do. And we will see a high level overview of all the tools that are used in DevOps. So this is day one. All right. Now for day two, we are going to understand the development part, the dev part of DevOps, right? Dev of DevOps. So we will understand version control systems, continuous integration, and various components of VCS and continuous integration, and how all the things come together. And on day three, we are going to learn about ops of DevOps. Right, so we will see how the operations work, what are the challenges for the operations, and how we can do a shift left and move ops more towards development. Okay, so we are going to do this for next 3 days. All right, so let's start with DevOps methodology. What is DevOps and how it came into being. All right. So to understand that, let me take a new page here. To understand that, we have to understand software development lifecycle. So I'm not sure, how many of you are already aware of software development methodology, how many of you have already worked on software development, or how many of you have worked so much that you live software development every day, right? So there could be a mixture of the participants here. So I'm just going to take you briefly on how the software used to be developed in the olden days, right? Although some teams or many teams are still following this, but this is now a methodology which is slowly getting obsolete, right? So let's talk about waterfall. Hmm? So let's say you have a client. Let's call the client as, let's call it as Applebite, for example, right? I'm not taking names from any organizations, but let's say there is a company called Applebite, and they give you one project, and the project is, for example, to develop a web application. Let's say this is a e-commerce web application, right? They want to be the next Amazon or the next Flipkart, and they want you to develop their web application and maintain it. Okay, so when this request comes in, you identify, okay, there's a potential customer, let's talk to them. So your design team and your sales team and your technical sales or whoever wants to talk to them, they will go and set up a meeting with them, right? And then once the ball starts rolling there, when the thing starts getting serious, you would want to capture the requirements from them, right? What are the requirements? What are the requirements of Applebite team? Do they want a website? We should have this feature. We should run this. We should be able to do this, blah, blah, blah. Your requirements. Let's not get into much details there. So you get the requirements, and then what do you do with the requirements? Yeah, you do a analysis of it. You do the analysis, and once the analysis is done, you get an approval from your client, or I would say an agreement with your client that says, okay, this is what we have understood, and the client agrees that this is what we are going to deliver, right? You have a commitment from the Applebite company. Then next step, what do? Next step is you start with the design, right? You start designing your application, right? You define what are the components that will go into your application, what are the third-party libraries, right? What are the modules that you are going to create, and then what will be your team structure and things like that, right? You design your system, and after the designing, you do a implementation, right? And this is the part where people actually work the most, right? You do implementation for a long time. You do implementation for a long time, and this implementation consists of development, and then test, and then further development, and then more test, and then more development, and more test, right? Finally, when the last test is done and everything comes as green, so all the tests are successful, you are ready to make a release, then you take this product and say, okay, now I release it, right? And because this is a web application, you may also be expected to deploy and monitor this application, right? So you do a deployment. You do a deployment of the application, and then finally your end users are able to access this application, right? This is a standard design flow. This is a standard development flow of waterfall. Now, this has been a tried and tested way to work, right? You talk to the customer, get the requirements, do the analysis, do implementation, and deliver. But there are some problems with this approach. And those problems have started to become evident given the pace of development and the technology change that is happening all over the world, in the technical world right now. Right? What are those problems? The first problem is time to market. The customer, let's say the customer came to you on 0th week, right? He came to you, you did your requirements, your analysis and design, and then finally you deploy your application. So much time would have gone by, right? Maybe very conservatively, we can put this time to at least an year, which would have gone by before your website would be live, right? For a big project. Maybe lesser, maybe more, but let's say it took 1 year, right? For example, it took 1 year to get this project out. The client, Applebite, came to you at the beginning of the year, and at the end of the year, they got their product. By the time they got their product, the competitors already had their product in the market. So they lost their leverage of being first to the market, right? So this is a problem. Second is change of requirements. Your organization, Applebite, may say, okay, initially we agreed that the website should be blue in color, but now we want website to be red in color because looks like red is the color that people like. So there could be a change of requirement in the middle of the implementation. And in Waterfall, it's very expensive. You can have the requirements changed, but it is very expensive. You have to go back to your design, change some design components, restructure your application, and then come back and continue the implementation. So change of requirements is very, very expensive, right? So that's why generally organizations don't change their requirements. Another problem is failure. Maybe by the time the development reached here, the teams understood that this is not our cup of tea. We cannot implement it. Yeah. It's like, no way. We cannot implement it. It's too expensive or it's too technically challenging and we don't have the bandwidth. And at this point of time, project fails. Right? Now the efforts that were put up to here are a waste. The money was spent without any returns. And the client lost so much of time, right? So you cannot fail early, right? So these are the problems that are really evident in waterfall model, and we can go much into detail. We can find some more problems and we can discuss more aspects of these failures, but for now, in the favor of time, we'll just stop here and then we'll concentrate on these failures as such. So how could we solve this problem, these problems which are positioned by this waterfall methodology? The solution, many of you guys would have already guessed, is to use another software development methodology, also known as any suggestions? Agile, right? We try to develop software in agile manner, right? What does that mean? That means that we do not commit for an entire project to be delivered. Okay, we commit that we will deliver very frequently and we'll deliver something which you can use immediately, right? So Applebite comes to me and says, hey, develop this web application, right? And in the requirements, they give us the requirements. and the requirements has lots of requirements. It should be red in color. It should have a login page. It should have a cart page. It should have a checkout page. It should have a inventory management and admin console, blah blah blah. There could be hundreds of requirements that the organization will give you or the client will give you, right? So guys, are these colors okay? Are you able to read them?
Ahmed, some people are saying that the color is not visible for them. And is there any chance that we can increase the font?
I mean, this is my handwriting. I mean, I can write bigger.
Okay, all right. Okay, it's a mixed response, but I think majority of them, I think they are okay with the color.
Yeah, maybe people who are watching on smaller screen may have some difficulty.
Yeah. So I'll just give a suggestion for all the participants. See, if you want to make a full screen, what you can do, on the right hand side, there is a red button with 3 dots. Click on that first. So it will become a little bigger. And if you want to make it full screen, maybe you can click on the F11 button on your keyboard. So that should give, make your screen bigger, and the visibility will become much better. Okay, over to you, Amit.
All right. So maybe I can use a white background. Yeah, some people are suggesting use white background. I can do that. No problem. So let me just take 1 minute here. I'll just use a whiter background. Maybe it'll help out. Okay, so let's talk here. Right. Again, if you guys have smaller screens, you will still face the problem of not able to read. But let's try it out. Right. So let me choose darker colors as well. Okay, so Agile, we said, we will work in Agile, and then, Apple Byte. It will give the requirements, and the requirements would be multifold, many requirements, right? And if you choose the waterfall way of working, then again you will fall into the same trap, right? So what you do, you say, okay, all right, we will work for 3 weeks. We will work for 3 weeks. In these 3 weeks, at the end of the 3 weeks, we are going to give you a working solution with very minimal features. Okay, so we will ask Apple Byte, hey Apple Byte, pick up your top 3 features, give them to us, and we are going to work and deliver them to you. Okay, Apple Byte says, okay, pick up feature number 1, feature number 2, and feature number 4. Pick these 3 features and develop them for me. So you work for 3 weeks, you plan, you code, and you test, and then you build, and then at the end, you deploy. And that's when you give it to your client, which is Apple Byte. And you say, okay, here we work for 3 weeks. Here are the 3 components that you asked for us to work on. And here you go. You can access the application here. Give us your feedback. And client says, looks good. All right. Then the development team says, okay, we will work the next 3 weeks again. And here, give us 3 more features. Right? So you say, okay, now this time, take feature number 3 and 5 and 6. This time take 3, 5, and 6. So you again do a plan, do a code, do a test, do a build, and at the end say deploy. And again give the feedback, get the feedback from the client. So this is called an agile way of working. Right? What does this mean? This means that the development team, instead of working for a very, very long time, 1 year or so at a stretch, will work for a smaller time duration called as a sprint. And during this time, they are going to develop part of the code which will make sense to the client, and then deploy it, and then get the feedback from client. In the meanwhile, client can change its requirements. Client can say, okay, I don't want requirement number 4 to be done, do 7, 8, 9, something like that. So client can prioritize what needs to be developed, right? So the development team works for shorter sprints and gets the thing out of the way, and then clients give a continuous feedback. Okay, so this is called agile. Now here you have a lot more things happening, like you have your client meeting, your product demo or sprint closure, sprint planning, backlog refinement, and your retrospective and things like that. But you are not going to go into much detail there. Technically, as a developer, you will plan, code, test, and deploy a set of features at the end of the sprint, right? Now, this is fine. This is fine. But cannot we take this a step further? Right? Cannot we take this a step further? Why are we waiting for 3 weeks to release this? Right? Why are we waiting for 3 weeks? If a developer is already done with their code change and the feature is developed, like for example, in the first 2 days of the sprint, feature one is already developed. Why are we waiting for the 3 weeks to complete? Why cannot we just deliver it? Right? Quick delivery, continuous delivery. If something is completed, just deliver it. Now, this approach is achieved via DevOps. All right. So here what happens is, again, Applewhite gives the requirements, and there are hundreds of requirements. Now, as a team, you will still prioritize by sitting with the Applewhite team, which is the number one priority, which is the number two priority, and things like that. But then the team will start working on feature one, the topmost priority feature. They will start implementing it, and then they will do all the changes required to implement it, plus do the tests, and then release. Right? Then, as soon as this is released, take the next requirement in priority, make all the changes and the test, and release. Right? So the delivery cycle becomes like this: develop, test, and then deploy. So you are continuously deploying. This is what DevOps does. Right? In Agile, it's the other way around. In Agile, it is develop, then test, right? Then again develop other feature which are part of the sprint, then test, and then at the end of the sprint, you do a deploy. All right. So guys, is my audio and screen clear to you? I've got many complaints that they cannot hear anything or the screen is not visible anymore. Can you guys hear me and see my screen? Okay, all right. Cool. Sorry for this interruption, right? So this is what happens here, yeah? And then again, continue with the dev test. In waterfall model, you continue long terms dev and then test, and then same thing at the end you deploy, right? So this is the waterfall model. You deploy at the end, right? In agile model, you deploy, but you deploy less frequently at the end of the sprint, right? And the DevOps model, you deploy continuously. So this is what DevOps is all about. Now, to achieve this, now this is a high level of automation. This is a high level of automation. If we have to deliver every time a feature is ready, well, it's very challenging. You want to ensure that the tests are in place, automatically tests are happening, and you want to ensure that all the checks and balances are in place before you actually make a release, right? So how do you achieve this? How do you achieve this? So there are several stages when you talk about DevOps. Okay, you must have seen this DevOps infinity cycle, right? Maybe I'll just make it here. I will say like this, something like this, right? What do you do in this infinity cycle? Well, for each feature, right? For each feature, for every feature that is to be delivered to the customer, first thing that you do is plan. You do a plan. Okay, how should the feature be delivered so that when we deploy it, it is usable? You plan on that way, right? Then what you do is you code it, right? Then you test it. Then you build it, right? Then you deploy it or release it. Let's say release, right? And then you operate it. And then you monitor it. And then you also get feedback. Right? So you start with, for example, now let's say you have your Apple Byte and there are a lot of features. Now these features, actually, you don't go by what Apple Byte gave. You say, okay, we will define how we will split these requirements so that when we deploy, it works for you. Right? Maybe entire application does not work, but every feature that we'll release will incrementally add up to your application and it'll start working. Okay. So what do? You plan how do you do the development, right? And then you code. And then code is implementation. Testing is also part of implementation. You code and then test, you code and then test, and then you build your application. And once the feature is ready, you release it, right? Releasing means baselining, packaging, whatever you want to do. And then you operate it. So that means deploying an operation. So you deploy it, run it, and then make sure that it is running stable, right? So you release after you completed, and then you operate it. Make sure that the application is healthy and running all the time. Then you monitor it continuously for any problems. If there are any errors generated, if there are any exceptions generated by the application, if the application goes down, your hardware requirements, your infrastructure monitoring, you have to do that. At the end, you get a feedback from your customers, and based on those feedbacks, you can add more requirements and then plan them as well, right? So you again get back to the cycle. So this is the DevOps infinity cycle. All right. And this is the level of automation that we want to achieve, right? So what do we want to achieve here? Let's say, understanding planning is not part of our training, or whenever you learn DevOps, you don't necessarily learn how to plan. Your learning starts from here, coding, right? And it ends at monitoring. So what you do is you try to develop a DevOps pipeline. A DevOps pipeline. Okay. And let's say your feature implementation is ongoing. Your feature is planned, right? And you start from feature is planned already, and then you start coding. So as and when your code is ready and pushed to a GitHub repository or any version control repository, your developers are working on it and they push the commit or the code change to the repository. It will initiate this entire pipeline, right? Any code change or any code commit, I will just write it, any code change in the project repository or project code base. Any code change in the project code base will trigger this entire pipeline, right? What will happen when any code change is done? You are going to maybe try to compile it if it's a compilable language. For example, if the project is written in C sharp or in .NET or C sharp or in Java or maybe in some other language, and you want to compile it, you do that. After compilation, you perform on all your tests, right? You want to see if the feature is working fine, if there are any regressions, if there are any other complaints or other problems in the code change that is coming in, right? And once the tests are done, you want to generate some metrics. For example, what is the code coverage? What is the static code quality? What is the syntactic status of the code? So some sort of statistics about your code. And if everything is fine, if compilation goes fine, test goes fine, and metrics code fine, you can also package it, make it ready to release, right? And package and upload it. So you can trigger these steps. Now, obviously, to achieve this, your compilation should be, that will be very light. Your compilation should be automated, right? Your compilation, your tests, your metric generation, your packaging, your upload, everything has to be automated. Otherwise, this will not work. Every code change, nobody is going to sit and click next, right? So it all has to be automated and integrated. So that means if compilation is successful, do tests. If tests are successful, generate some metrics. If metrics are also successful or are within our quality criteria, do packaging and then do upload, right? So you perform these actions. And these actions will ensure that at the end, whenever a code change is done, all these tests are done, and it will ensure that you are always ready to release. You are always ready to release, right? And this section or this pipeline is known as, any ideas? This much pipeline, what it is known as? This pipeline is known as continuous integration, right? You integrate continuously. You are testing your project continuously. This is called CI. This is not CD. This is CI. Now, as you saw here, you do code, you do tests, you do build. We are doing here, right? Compilation, tests, and everything we are doing here. And we are ready to release here. But we are in this pipeline, we are not releasing it, right? The next step we can do is also, maybe choose a highlighter here, also to deploy on staging or deploy for customer feedback, right? You deploy for customer feedback. Customer feedback, right? And the customer will perform their own user acceptance test. So this means that you have released to the customer. Okay. Now, if you are doing this for every code change, for each code change, if you are compiling, testing, and then finally deploying for a customer feedback, that means you are doing a continuous delivery. You are delivering to your customer continuously, right? This is called as CD. But if you also automate this UAT, or if your customer has automated this UAT, then you can go further one step and say that we deploy on the user test environment, and we also run automated user acceptance test. Once those tests are successful, right, you do your UAT, and if the UATs are successful, you do your deployment to production. That means to end user directly, right? If you deploy to production, every code change, if it is going to production, then it is called as continuous deployment. Then it is known as continuous deployment, right? So CI is making sure that your project quality or the code change quality is always okay and you are always ready to release. CD or continuous delivery is when you say, okay, I deploy it for customer feedback. Continuous deployment, another CD, is when you say any code change, I will automatically verify everything and deploy it to the production. So this is what the CI and CD is known about. But this is just CI and CD. What you do after the deployment is done, you want to monitor it. Let's say you deployed your application here, right? You deployed your application and your application is running. You want to monitor the application, right? Maybe if application is taking a lot of time to response, then you want to take some actions, right? Or you want to give feedback to the development team that their application is running slow, right? You also want to operate it. What do you mean? Maybe during the um, uh, user activity, there is high load on the application servers, so you want to scale them. You want to scale up or scale down, right? You want to upgrade. You want to migrate. Maybe a lot of things you can do to ensure that the application is running properly. So you want to operate or you want to run operations. So you want to do all that stuff. Now, all this stuff should also happen automatically. Your operations should be automatic. Your monitor should be so tightly integrated that the developers get a feedback as soon as something goes wrong, or your infrastructure team gets a feedback when as something goes wrong. So how do you do this? These are purely operational topics. Operating the application, monitoring, giving the infrastructure for deployment. All these are operational topics. Now, if you talk about operational topics, they are far away from DevOps, from developers have their high stakes in changing their code, but the operations guys don't want to change their infrastructure. They want to have stability. So they will say, yeah, I will not going to scale up your application because I'm afraid my infrastructure will crash, or I'm not going to set up any extra monitoring for the application because I'm not sure if my monitoring infrastructure is competent enough for that. Now, to get away from this problem, right, you bring your development team who work on this side of the world and your operations team who work on this side of the world bit more together. How do you do that? You try to create an infrastructure where the development team has a lot of control over the operations. Okay, so the development team can design their own deployment infrastructure. They can design how the scaling happen, how the operations happen. They can design how the monitoring happens, right? Okay, so these are some challenges which are solved by DevOps. So at the end, DevOps brings the developers and operations together to ensure that you can do a continuous delivery, continuous monitoring, all those things, continuous integration. You can enable all these things by bringing the development and operations team together. That's what DevOps is all about, right? You should understand what DevOps is all about. Now, what are the tools you want to learn and all that will come later, but this should be clean. Okay. Now, to achieve this DevOps, this CI pipeline, the CD pipeline, and then DevOps or DevOps together, you want to understand how these pipelines are implemented. What are the various tools that we use? So, what are the tools that you use for storing the code base? For example, you should know Git, right? For compilation, you should know maybe a build system, maybe for example, Maven. For running tests, you can have maybe Selenium or Cypress, some testing tool, or JUnit for unit testing. Depends what kind of testing you are doing. For metrics generation, you can do, say, let's say Sonar Cube or Jacoco, Java code coverage, or anything else, right? For packaging, depends on what kind of deployment you are doing. You may need to know maybe Docker, right? And for upload, then Docker will only take care of uploading to registry and the things like that. And then when you are deploying, you deploy to a containerized environment, so you should know, all right, Kubernetes. And if you know Kubernetes, you can have deployment infrastructure as well as a very close operational infrastructure. Okay. And for monitoring, you can have Prometheus, or Prometheus plus Grafana, for example, or any other monitoring tool, maybe AWS CloudWatch, things like that. Yep. And to set up entire this infrastructure, you want to set up or maybe you can use Jenkins for integrating all these together for this entire pipeline. You will use Jenkins will take care of uh, sensing a new change and then compiling and testing and blah blah blah. So Jenkins will orchestrate all these things, right? And to perform all these tasks, you need infrastructure, underlying infrastructure, right? So to set up the underlying infrastructure, you need to know some infrastructure provisioning tool. For example, your Ansible, right? Or Puppet. Or if you are on cloud, then Terraform, for example. Yeah. So you can use these solutions to ensure your infrastructure upkeep. Now, having these tools like Ansible, Puppet, or Terraform for managing your infrastructure, Kubernetes for managing your Kubernetes infrastructure, these tools actually make life of the developer easy, because they can also maintain their Kubernetes workloads and Terraform configuration files and things like that. So they don't need so much of operational guidance there. Right? So these are the tools that you should know, and there are a lot of other tools that you may want to know. For example, I have taken this diagram here, and this is a very famous diagram, and many people use it to define what are the tools that you should know. So for planning, you can use Jira and stuff and other planning tools. For building and coding and all that, you can use Git, Kubernetes, Docker, GitHub. For continuous feedback, you can have some customer management solutions. For continuous integration, you have Jenkins or other CI solutions. For deployment and operations, you can have similar solutions, right? So there is no limit on which tools you can use and what you can learn. But in the next session, we will understand the dev part of it, the CI part of it. We will understand what is Git, how it works. We will understand what is Jenkins, how it works, and how it brings all these things together. Right? So this is all for today. This is all what I wanted to discuss for today. Tomorrow we continue the discussion, and we talk about Jenkins. Let me clear this page. We will talk about Jenkins and version control system. So we will see some hands-on on how Git works and how Jenkins brings it all together. Again, we will not go much deep in tech, deep technically. I'm going to develop a pipeline for you and just show you how you can do things. And maybe later when we, go for full-fledged uh, training sessions, then we will, talk about it. Okay. All right. So now I can take some questions. Okay, we still have around 10 minutes, so I can take some questions. I will not be discussing on agile topics here. I saw many questions on what happens if this happens, what happens if that happens. Well, those are agile discussions. We will really we will not benefit by discussing agile here. So I encourage you to read about it on your own, right? And think about agile, right? Any questions on the DevOps tools and what is DevOps and how everything's work together? We can talk about it. Zabbix versus Nagios, which one you prefer? So Nagios is the one which I have used, but slowly the world is moving towards containerized solutions. So there, mostly people use Prometheus. Are there any specific? Okay, the questions are coming at so rapid pace that I cannot keep an eye on them. Are there any specific industries that use DevOps? Well, DevOps is very, very highly used in web application development, for example. But it is also now being used in most of the technologies. Even with Waterfall, you can have CI and CD and a lot of bits and pieces of DevOps implemented, for selective use cases. Is it necessary to be on cloud for DevOps? Well, DevOps works very nicely with cloud, because if you have cloud, then you can work on all these tools. You get quick access to the infrastructure, you get managed services. So it becomes very easy to implement the DevOps principles that we have talked about. But it's not a mandatory requirement. You can also work on premise. What do we need to be aware of multiple tools as do we need to be aware of multiple tools as part of DevOps? Yes. What is the testing team scope of work in DevOps side? So when you have a testing team, right, the tests are the most critical part of DevOps. Unless you have tests which can give you the confidence that the DevOps is, or the code change is coming, is high quality, then you cannot be ready for release, right? Your tests have to be mature. So automation of tests is something that is the most difficult thing to achieve while going for CI. Kindly confirm when we will get the link for tomorrow's sessions. Okay, I'll let SkillUpRight take this. What are the prerequisites according to you before starting with DevOps? So you should understand software development methodology. So I think with my explanation, you would also already know, but do some reading on what is software development and how it is done. And also you should know Linux. But Linux is compulsory. Everything is on Linux. Your servers, your development, everything will happen on Linux. So you should know Linux. Difference between agile and DevOps. We discussed this in detail. What is metrics? Metrics is information about your code, like how many lines of code are tested. What is the complexity of the code, things like that. More on UAT. UAT is the test that is done by the client, so that they can run their own test and be satisfied with the applications that they are receiving. Right. Prerequisites to become DevOps engineer. I answered this. Can you please elaborate about testing in DevOps? I answered this. Will DevOps using Microsoft Azure DevOps tools will also be explained? I will not go into very, very specific tools. I'll talk about only high level tools like Jenkins and Git. And in the next session, or the session after that, we'll talk about Docker and Kubernetes. And then you can translate that, or transpose that to your cloud specific understanding also. Are you going to explain how to design pipeline? Yes. Do you have any study materials on today's topic, please? Well, Google is your friend. Yeah. I don't have anything offhand right now. Dun, dun, dun. Let me find more questions. As you said, how much time is needed to learn DevOps? That's a very subjective question, but you will need quite some time and some dedication. As you said, Jenkins manages total flow, then why we need different tools? Okay, we'll talk about this tomorrow. Is DevOps automated agile? No, there is a difference between DevOps and agile. GCP or Kubernetes? I don't know. Those two are not related. Maybe you are saying GKE or Kubernetes, but those two are unrelated technologies. Kubernetes is something else, and Google Cloud Platform is something else. Can you please elaborate about testing? I already answered this. Difference between continuous delivery and continuous deployment? That is answered. Is it mandatory that DevOps engineer must know scripting? Yes, you should know scripting. After you know, if you want to be a successful DevOps engineer, you should know scripting. Coding is good to have. How Agile and DevOps are connected? Can we not use DevOps Waterfall if project has multiple? Yes, you can use specific pieces of DevOps. For example, you can deploy a replication on Kubernetes without worrying about other parts of the cycle. Right? So you can adopt bits and pieces of these technologies for waterfall models as well. As a beginner, what way need to follow to become a master? Well, practice, learning and practice. How to decide which tools are suitable for a project? Well, it depends on a lot of factors, right? Which tool has the most popularity, which has the good support from the vendor, and what capability of which tool you have in house. What are the fundamental differences between DevOps and Agile? I discussed this. We will not go into much detail. Will DevOps using Microsoft? This I answered. Will you be explaining how to design Azure pipeline? No, not specific Azure. Does DevOps guys need to know every tool at expert level? So no, not every tool at expert level, but maybe tomorrow we will talk about T profile. What is a T profile and how do we work with that? But yeah, you should know almost all the tools at a very, very satisfactory level. Where may we find the recording of the session? I'll let SkillUpRight answer that. Do we have different applications to be used for Windows and Linux? We will not talk about Windows at all. PDCA is also part of DevOps. I don't know what is PDCA. My God, there are a lot of questions. Very difficult to cover all of them. Are we going to cover how we can add the Git and build using Jenkins? Yes, little bit. Yeah, not in detail, little bit. DevOps isn't a platform. If we combine all these tools, only we call it DevOps. Yes, if you achieve this, then you have DevOps. That's it. How you achieve it is very, very challenging. Can DevOps also use for mobile applications? Yes, I have TFS and AWS. What else I can use? You can live with AWS. You can have AWS and do your labs there. Do we need to learn Maven or Selenium for DevOps? You should know. I mean, no harm in knowing, not mandatory. Right? Okay, so there are a lot of questions. There are too many questions. I don't know how to answer that. How to answer all of them, right? So I'm really sorry if I could not take your questions. Maybe you can share the questions to SkillUpRight, or they are taking note, and I will try to answer them offline. Okay, so I really apologize because I could not take all the questions, but yeah. Okay, so tomorrow we continue the discussion and we talk about CI and Jenkins. And till then, be safe, and I will see you tomorrow. Right? So hopefully by end of the seminars, you will have some understanding of DevOps and tools and how do they work. And if you guys are interested, then in the tomorrow sessions and the day after tomorrow sessions, I will also share some reading materials. Okay. So Vinod, maybe you can also share how the participants can get the recording once again, and also how they can join next session. Seems like many of them do not have link for tomorrow's session. And guys, I really hope you liked the session. I was very high level, very precise, and a bit fast also maybe, but I did how much ever justice I could do with the limited time. Okay, thank you. Thank you, everyone. Have a good day. Bye.